Hello. Today, we're going to begin our discussion of nomenclature of various types of compounds. Nomenclature is simply a fancy word that means how to write the name or the formula of a particular compound. There are two types of compounds, ionic and covalent or molecular compounds. We're going to start our discussion with the simplest form of ionic compounds, which are binary ionic compounds. Before we can discuss nomenclature, there's a few points regarding ions and ionic compounds we need to clarify. First of all, a reminder that ions are atoms that have a charge as a result of losing or gaining electrons. Positive ions, also called cations, are formed by metals that lose electrons. Some examples of metals located on the left side of the periodic table would include sodium and magnesium. One can name a positive ion by using the element name followed by the word ion. A sodium 1+ ion is simply called sodium ion. Negative ions, or anions, are formed by nonmetals, substances located to the right of the stair-step line on the periodic table, gaining electrons. Some examples of nonmetals that gain electrons are fluorine and phosphorus. Negative ions are named by using the first syllable of the element name and adding IDE followed by the word ion. There are a few notable exceptions to the first syllable rule. You'll learn those as you make your way through this video and examples in class and in the textbook. But one example of a negative ion is P3-. P, of course, is phosphorus. This is then called the phosphide ion. You might recall that several monoatomic, meaning single atom, ions can have their charge deduced from the periodic table, specifically from the group in which the parent element of that ion is located. Remembering that all elements located in group 1A have a 1+ charge. All metals located in group 2A have a 2+ charge. Aluminum, the metal located in group 3A, has a 3+ charge. In terms of nonmetals, all nonmetals located in group 7A have a 1- charge when they form ions. All nonmetals located in group 6A have a 2- charge when they form ions. And all nonmetals in group 5A have a 3- charge when they form ions. This chart inadvertently omits the phosphorus ion, the phosphide ion, P3-, which also should be shown in group 5A. Now, let's talk a little bit about ionic compounds. Ionic compounds are formed when positive metal and negative nonmetal ions combine. When the positive ion and the negative ion each consist of only one type of atom, in other words, they are monoatomic, they are called binary ionic compounds. Those compounds are the focus of the remainder of this video. When we talk about writing formulas for binary ionic compounds, there is one golden rule. And that is, when writing the formula, the net charge on the compound must be equal to 0. You'll see this rule over and over again as we discuss naming and writing formulas of various types of ionic compounds. The second thing to recall or to know is that positive ions are always written before negative ions. When we are writing formulas, we use subscripts to indicate the number of each type of ion present in the compound. The subscript 1, however, is never used. One of any type of an ion is simply indicated by the presence of that ion symbol in the formula. A couple of examples. Suppose we want to write the ionic compound, the formula of the ionic compound formed when a potassium ion, K1+, combines with a chloride ion, Cl1-. Well, 1 plus 1 - equals 0. So we only need one potassium ion and one chloride ion to combine and form KCl, which is the formula for potassium chloride. We'll learn how to write the name of that compound in just a moment. Let's look at a slightly more complicated example. Suppose we want to write the formula of the ionic compound formed when a sodium ion, Na1+, combines with a sulfide ion, S2-. Now, 1 plus 2- does not equal 0. Matter of fact, it equals 1-. In other words, to make this compound, we need 2 Na plus and 1 S2-, because 2 times 1 plus is 2 plus. 2 plus 2- equals 0, which means the formula of this compound is Na subscript 2S. Having looked at a few examples, let's check to see if you are understanding the process that we are discussing. When you look at these check for understanding questions, read carefully through the question. Pause the video, come up with the correct answer, A, B, C, or D, and then play the video to check your work. In this first question, we are asking which of the following is the formula of an ionic compound formed when aluminum ions, Al3+, combine with sulfide ions, S2-. Pause the video and consider your answer. Once you've come up with a possible solution, resume watching the video to hear a discussion of the solution. The correct answer to this question is D. In order for the total charge to equal 0, we will need 2 Al3+, because 2 times 3 plus is 6 plus, and 3 S2-. 3 times 2 minus is 6 minus, and 6 plus and 6 minus equals 0. If you look at all of the other choices, the total charge on any one of these compounds does not add up to 0. The only viable choice here is choice D, Al2S3. If you can name ions, naming binary ionic compounds is really, really easy. Let's look at 3 examples. On the left, you see 3 different compounds. Let's start with the first. NaF is the formula of that compound. Let's identify the formula of the positive ion in that compound. Remember, positive ions are written first, and they are metals. The formula in this case is Na1+. Recall that we named that positive ion the sodium ion. The negative ion is F1-. Recall, we take the first syllable of the element name. In this case, the element is fluorine. So we take fluor, we drop the INE, and we add IDE. So F1- is the fluoride ion. To name the compound, you remove the word ion from each ion's name, and slam the remaining text together. So NaF is simply sodium fluoride. Let's look at a second example. MgBr2. In this case, the positive ion is Mg2+, the magnesium ion. The negative ion is Br1-, the bromide ion, which means the name of the compound is magnesium bromide. Yes, there is a 2 after the Br, but that is only present to make sure the total charge adds up to 0. In this case, it doesn't play any role in the name. The last example is similar to one we looked at earlier in terms of its formula. Now we have the compound Al2O3. The positive ion is Al3+, which is the aluminum ion. The negative ion is O2-, which is the oxide ion. The name of the compound is aluminum oxide. Now, if all of our compounds contained ions from the representative or main group elements, our discussion of naming binary ionic compounds would be over. Unfortunately, some ionic compounds contain metals with more than one charge. These are metals that are not from main group elements. In other words, typically referred to as transition metals. Transition metals and metals from group 3A, except aluminum, 4A, and 5A, can produce ions with multiple charges. For example, an iron can produce Fe2+ ions or Fe3+ ions. This adds a complication when naming compounds. Now, before we talk about that complication, it is worth noting that there are a few exceptions. Notably, in group 3A, aluminum, as we've already discussed, always forms 3+ ions. And within the transition metals, silver, Ag, only produces 1+ ions. Zinc, Zn, only produces 2+ ions. And cadmium, Cd, only produces 2+ ions. We'll talk more about why these exceptions exist in a later portion of the course. For now, simply commit them to memory. The exceptions are named with the standard rules I just discussed. The remainder of the transition metals and metals in group 3A, 4A, and 5A on the periodic table must follow a special set of rules that we have to discuss. Specifically, we need a process that allows us to determine what charge is present on that metal ion before we can craft the name of the compound. This is probably best illustrated by looking at an example. Let's use the example of CuCl2. The total charge on the compound still has to equal 0. We don't know what the charge on the copper ion is, but we do know that 0 must equal the charge on that copper ion plus 2 times the charge of the chloride ion. And we know because the chloride ion is from chlorine, which is located in group 7A on the periodic table, it has a charge of 1-. So if we write a little mathematical equation calling the charge on copper x, we could have an equation that says 0 has to equal x plus 2 times 1-. We now have to use our algebra skills to solve for x. And if you do that, you'll note that x equals 2 or 2+. That means that the charge on the copper ion in this case is 2+. We have a Cu2+ ion. Now that we know the charge on that copper ion, we can name the compound. We're going to follow all the rules for naming that standard binary ionic compound that we just talked about, except we are going to insert a Roman numeral in parentheses after the name of the positive ion that is going to be equal in value to the charge on that metal. So, CuCl2. We just calculated the charge on the copper ion to be 2+. So the formula and name of the positive ion then is Cu2+, which is the copper ion. The Roman numeral, because the charge is 2+, will be Roman numeral 2 in parentheses. The formula and name of the negative ion is Cl1-. You'll recall it's a negative ion. It's the chloride ion. Drop the word ion from the positive and the negative ion's name and combine everything together. The name of CuCl2 is copper 2 chloride. The Roman numeral is only necessary if the compound contains a metal that is from the transition metals or is in group 3A, 4A, and 5A, with the exceptions noted previously. Other metals, those from the main group or representative elements, do not require a Roman numeral or require you to go through this process. Let's look at a few examples. Again, we're going to check your understanding. Read through the question, pause the video, come up with a possible answer, and then hit play to receive an explanation on the next few slides. The first question is, which of the following is the correct name for Li2S? Because Li, lithium, is a group 1A metal, no Roman numeral is required, so choice B can be eliminated. Li, 1 plus, is the lithium ion. S2 minus is the sulfide ion. The proper name for the compound is lithium sulfide. You should ultimately have come down to choice A or choice B, as we have not yet talked about sulfate or sulfite. Those will be discussed in a later video. The correct answer is A, again, because lithium is a group 1A or main group metal. It does not require the Roman numeral. A second example. What is the correct name for AuCl3? Pause the video, come up with an answer, and then hit play to see an explanation. The proper name for AuCl3 is gold 3 chloride, choice B. Your options should have been limited to A and B, as you recognize that Au is gold, not silver. Silver is Ag. Because gold is a transition metal, it does require a Roman numeral, making the correct answer choice B. Let's look at one more example. This time, let's take a name and try to come up with a formula. What is the formula for iron 2 oxide? Pause the video, select your answer, and then hit play to see an explanation. The correct formula for iron 2 oxide is actually choice D, FeO. Let's break this down a bit. Iron 2 oxide, the Roman numeral 2 tells you the charge on Fe must be 2 plus. Oxide tells you that it is the O2 minus ion because oxygen is located in group 6A. 2 plus 2 minus equals 0. Therefore, the correct answer is choice D. Some of you may have selected choice C, Fe2O2. Fe2O2 does have a total charge that adds to 0. However, it does not have the lowest whole number ratio of atoms present in the compound. And it is a requirement when writing a chemical formula that you have the lowest whole number ratio of atoms. Therefore, FeO, after dividing both sets of atoms by 2, is still the preferred choice for iron 2 oxide. Nomenclature of any compound type is not trivial. Practice makes perfect. See your textbook, homework, and instructor for many, many more examples you can practice to become comfortable with writing the names and formulas of binary ionic compounds.